Dale Dougherty, welcome to the Oracle Groundbreakers podcast.
Thank you. Glad to be here.
It's really great to catch up with you. You and I met many years ago, actually 2004 probably, and you are all things Make, so the head of Maker Faire, Maker Magazine, actually a Make Magazine, Maker Community. Yeah. And over there on the other side there is Chris Bensen. Chris is an engineer on the team with me. We're both on the developer relations team, so we talk to developers all the time. But Chris is unique, and that's why I wanted to have a conversation with both of you here, because Dale, you make things, and Chris makes things, and I like to talk to people who make things. I actually come from the construction industry. I used to drive a truck and a bulldozer, and I built houses, and so that's how. But that was a long time ago when I actually had hair. So Dale, when you and I met, we actually met in a restaurant in Palo Alto with Denise Cooper and Simon Phipps and some other people from O'Reilly, because at Sun, we were actually starting the Open Solaris project at that time. And you told me at that time, this is, you guys were going to help out with community building and stuff. But you said to me, kind of whispered in my ear, that you're starting this new project, and it's a magazine. And I said, are you actually going to print it on paper? And I said, everyone's getting out of print, Dale. No one's doing print anymore. This is, everyone's leaving print, right? Everything's online. And then I saw the magazine, and it was beautiful. And I actually used to work in a magazine as well. The typography on your stuff was beautiful. The paper stock was beautiful. It had a spine on it, so it was like a book. It was beautiful. And so that's how I first heard about Make, all the way back then. And so I wanted to have a conversation with you about community building, because you and your team and everybody involved with Make has built a massive community over the years. And Chris and I, we do community building as well. So figured we'd have a conversation. And so tell both of us, what's new with Make?
Well, to some degree, we're sort of slowly emerging from the pandemic here. And, looking back over the last year, the maker community really responded quite effectively to pandemic and used maker spaces and used the tools they had. More importantly, just used their own mindset to figure out things needed to be done, like face shields and other forms of personal protective equipment. And, and sadly, we kind of saw a societal failure happening at the same time, that everything from supply chains breaking down to institutions that were used to ordering on demand what they needed, not being able to do that. And to some degree, a public health crisis in which information was it was hard to tell what was truthful and what was good information and bad information. So I just I look back on it and thinking, well, many people might ask, well, what's the value of makers, or what do they do? And then this crisis happens, and they're among a group of people, and there are others, but they step forward, or self-organized. There was no coordinating body for all of this, really. That was just people talk to each other. I kind of credit Neil Gershenfeld of MIT's Fab Lab. It's the basic idea that that designs for physical things are digital files, and they can go anywhere. But you need the equipment to make them or replicate that device or that machine, and that's what we saw. So. Joseph Prusa in Czechoslovakia came up with a face shield, and makers, smart ones, took that and they just made that, and then they found ways to get it into the hands of local community, healthcare professionals. And sometimes what was interesting is they went to the hospital said, no, we can't take that, it's not authorized. But then they went and talked to friends of friends who were doctors and said, oh, my goodness, that's exactly what I need.
Right.
Drop them by my house and I'll bring them in. Right. So, it really was almost that classic internet phrase of routing around a problem.
Right.
that makers had to do, and it kind of goes back to the virtues of hacking and not taking no for an answer, figuring out how to do something, even though on paper they weren't qualified to build medical devices or anything close to that. There was a need, and they responded to that need, and I think we learned a lot about our community during that time.
Yeah, it's really interesting to hear you say that, because I mean, every person, I certainly agree with it, obviously, but every person I talk to in this field has this self-initiation. They see a problem, or they're just interested in something. But if there's an immediate problem, to be solved, they jump on it. All my conversations with Chris, this he always says this. I got this problem. I'm just going to go out and fix it. I'm just going to go out and build it. He's not going to call somebody. He's going to call the plumber. He's going to fix it himself, kind of thing. Yeah. And I mean, it's really interesting that we find ourselves in this position. I'm sorry, you're going to say?
Yeah. Well, I was just going to say, it kind of gets to the other things that I'm doing in a way, is say Chris as an example here, and really my life at O'Reilly and working with makers, whether it was early web or open source. I saw a group of people that had a disposition
right.
to just do things.
Yeah.
And they would learn any way possible. They would learn from any source. But it could have been an O'Reilly book, right? It could have been an online. It could have been asking a friend. It could have been just repeated attempts to figure it out through trial and error. And I've been really, to me, that seems like such a valuable perspective, a life gift, if you will. And how do we give that to as many people as possible? And I kind of wrap that into what I call a maker, and say, how do we create more makers? Like if you got exposed to this and you figured it out, you become a maker. But if you don't get exposed to it, how would you even know this is possible? I kind of use the example of athletics. If we didn't have ball fields and leagues and facilities and coaching, a kid would never have the opportunity to figure out if they're athletic or not.
Right.
They would never play the game. So how would you know? And I think when it comes to these somewhere orientation, science and technology, a lot of young people never engage in a way that helps them discover their own motivation and their own interest. It's too often in school it's forced on them, and it's just sort of the idea of learning without doing. So that's the other thing that really fascinates me is makers are a kind of template for, I think, a future generation that we'd like to build more of, and it should be more inclusive and more accessible to more people. And really look at these as habits of mind that can be trained into people, but the kind of important part, and this is sort of, you can't impose it on people, right? And like you kind of said, you kind of have to discover it. It's like a lot of good things, and you have to become aware, you have to want it yourself, and you have to pursue it. It's not a curriculum in a sense that can be just put on paper.
Yeah, there's a mindset. It's a thinking. It's a problem solving. It's a noticing that there is a problem to solve. A lot of people all too often, at least nowadays, they turn to the web when there's something that they need, and they go to a shopping site, not how do I make this? How do I do that? But they don't necessarily have the tools. They don't have the mindset. Some people are more born with it, or have that in their household growing up. Like my dad, we had a wood shop. We built the house, all kinds of stuff. And I remember in fourth grade, my parents weren't home, and they came home to all the stereo equipment, the TV, which was dangerous because of the giant capacitor, the VCR and the stereo and the speakers, everything. The whole entertainment center was taken out and laid across the living room. And if my parents were different parents, because I had other friends who took things apart and their parents got mad at them, my dad just says, well, I guess you're going to have to figure out how to put it back together.
which sometimes you were able to do.
I had a couple screws that were extra, and that's almost always the case.
Yeah, no, but the important thing, I mean, that example just highlights two things. One is the value of learning from experience, right? Of actually doing that, taking it apart, and you could fail at it, right? And you ideally you fail in small ways that you go, oh, well, I didn't figure that out, I didn't know that, so I could recover and do that. And then it's kind of the other side that I think is so important. That wasn't in school that you were learning that was at home. It was in your environment. And I think one of the things I've talked a lot about is just how important that this is part of your life, not part just of your, formal education, because, there's an idea anyway. I think it's reasonably true that, in America, some of our golden age of engineering is kind of the 50s and 60s. And, many of those people grew up on farms or in families that worked in factories. They would have been around machines. They knew that. When they got to, a college level engineering course, they had this really deep background in how things work. Just intuitively, they knew that. And then they got some theory, and they married the theory and practice. And what we see too often in today's generation is they're just teaching theory to the same group that's never had the practice. And so, what I kind of argue a lot in Maker programs is that you're actually trying to put practice in the foreground and put theory in the background. That you have to be able to do this. You have to. So, like MIT was, I was talking to someone there. They were teaching, machine design theory to students that didn't how to operate or have been around machines. So it's very difficult to just at an abstract level talk about machines if you don't have that actual use around it. So, so it's kind of important that we have these experiences in our lives. And if we're not, and maybe one of the difference that I see today is often like your dad had a workshop and you benefited from that. But if my dad didn't have a workshop, so I didn't have access to that, right? It wasn't something my dad did. But I hope with like maker spaces and hacker spaces and other things, we can make access to workshops, wood shops and metal shops and electronic workbenches and everything. We can give access to more people.
Right.
It's kind of like a kid that, his father belonged to a golf club, and so he picked up golf, right? And if your father didn't belong, you just didn't get to go to the golf club. And so that just creates an inequity, among who gets to develop those capabilities. And so my belief is we all have these capabilities, but our society and sometimes our culture doesn't do enough to foster it, doesn't bring it out in people. And if I have sort of a goal in things like Maker Faire, it's to put it on display for people to see how wonderful it is. Then when people can, what people choose to do, and it's not being determined by some top-down force. It's just people figuring out this is cool, and I think at the core of making is kind of curiosity. That you have to be curious about a problem before you engage with it. Like, what's causing that? If you're not, so I think sometimes in school, teachers give out the problems to students, right? And so that's not interesting to them. Rather than engaging them in a way that they start thinking about something and say, that's an interesting problem. And once you find it interesting, you'll spend a lot of time trying to figure it out. If it's not interesting, you'll just do the minimal work and be done. So I think it's kind of finding interesting problems and problems that interest you is kind of one of the core pieces here.
Well, that's why I think this is why this really took off. From 2005. You started the magazine in 2005, early 2005. I think I met you in the winter of 2004, people were hungry for it, And then I eventually moved to Japan, and the only Maker Fairs I've been to were up in Tokyo. I live in Osaka now.
Yeah. Right.
And what was so cool about it, my first experience was everyone was walking around with a magazine, and it was held at a university. So it had that sort of no frills, sort of a thing. Well, all the demos and everything was set up in the gym, and then actually in classrooms as well. And you had to sneak your way around the university, and there were thousands and thousands and thousands of people there, talking and hacking on things. And it was so cool. I just would walk around. There was no frills. All the signs were handmade and everything. And I was just walking around. I mean, I'm into photography, so I'm basically taking pictures. And at the time, I was hanging out with the Tokyo Hackerspace, people who became quite famous a few years later, and I'll tell you about that. But listening to the conversations with the people in the booths, they were so passionate. This guy, he built, whatever he built, a little, drone or something, it does, whatever. And he built it with his own hands, and he's explaining in the most insane level of detail.
Yeah.
Right.
I'm really glad to hear you say it, because my core idea for Maker Faire was to create conversations with makers, make it possible for people to just talk to them. You could see it in their eyes, how excited they are about what they do. And these might be people that are otherwise shy or awkward, but they have something, between them and you, and it's that project that they want to talk about. And I thought, where else do we get to ask these kind of questions? Like, hey, how'd you get that idea? Or where'd you get those parts? They're kind of unusual. Or, how many times did it take you to do this? And blah, blah, blah.
And they knew everything.
It's a great conversation. Yeah.
They knew
everything. It's a great story. It's a great story.
I would just listen to this. And some of it was in Japanese, so I was like, oh, God, I got to listen to 2 languages. And they go into this insane level of detail.
Yeah.
And then, of course, outside, I'd walk outside for a break, and I'd see the generators outside with the big, huge, cables, which were, powering everything inside. It was all very physical. And even when they were having software conversations, it was all very physical. And this is why having conversations with Chris is so interesting, because although we do, we do mostly software, we like to, put the software inside of something that's physical, right? And so when we go to our conferences, we build experiences and stuff. And that's that same sort of a energy that we're looking for, is for people to come into the lounge, hang out, have some interviews, have some conversations, have some food, go through one of the demos, not just slides, but actually, hands-on. So Chris, I mean, so tell us about some of your experiences in the Hacker Lounge, or in the Groundbreakers, lounge that we used to call it, with some of the people, with some of the stuff that you've built.
Well, the first thing that came to mind when you were talking about the experiences and hands-on is I built 2 full size. When I say full size, they're 8-foot cubed rooms that were portable. That were escape rooms. So inside one of them was it was a superhero themed. So you go in, you press a button, it shuts the curtain on, powers shut, and you've got 5 minutes, because it's at a conference. You got to get things going quick. And there's Thor's hammer that you can't pick up. There's Captain America's shield. There's the arc react, Tony Stark's arc reactor. There's a bunch of things, and there's software, obviously driving a lot of these different things. And you got to figure out how to pick up Thor's hammer. So we tie in the themes to software and stuff. And then we had the other one, which was called Duke's Lab, and you have to hack some. There's a little computer there. You had to do some hacking on that to try and get the codes to defuse the nuke. So, and we had this Indiana Jones style box you had to open up, and the countdown timer starts ticking on this nuke. A nuke. It's a giant, like, 10-inch PVC pipe with 3D printed ends on it, and a printed LCD display sitting on the top. But there's all this electronics in it, and software, driving this whole thing. So it's very interactive, and everyone has a smile on their face, when they come out of it, and this hands-on experience. And they don't even necessarily go in there, and they don't have to be a software engineer. They don't have to know what's going on. We talked about Dale, you talked about some education and stuff like that. I've taught makers clubs, and that's kind of when I've when I, resonated with the children, it was about, like what you said, they have this problem. So in this case, the escape room, and people have to figure out how to solve it. They have to learn something.
Yeah.
Whether they use their phone to look up, something, or whether I didn't care. What was the thing? It was converting hex or binary to a number that was on the clock, on the lock. I mean, to open the box, and it's small, it's inconsequential. And this is the, for me, this is the first escape room that I've never gone to escape rooms. And so I had to look online, and I almost went to one to go figure out, but I didn't actually have the time. And I'm like, well, we need to, what do we need to do for this experience? So I had, talk about what you're talking about. I had to learn how to do that. And I've been to one escape room since, but I've built 4 of them. So but they're not full rooms. They're 5 minutes instead of an hour. So it's different, but
that's great.
It's still, what I learned is, from that, and that was trial and error, is some things were hard. So I when I built the room, I had it so that I could monitor the first few people that went in, and I could tweak the room a little bit so that I could make it easier or harder. And there were a couple people that I knew, I knew the people, so I knew they were pretty smart. And so I kind of dialed up the settings to make it more difficult. But it goes to your point of how we educate children. And if it were me, if I were running everything, I would revamp things in a lot of different ways, and instill maker stuff, because the makers clubs that I've taught at, I boiled it down to, everyone wanted to program, teach the children programming, and Scratch was fun and interesting, but they didn't have a thing that they wanted to build. They didn't have something they wanted to solve. So I boiled it back down to, after a few clubs, I boiled it down to they knew straws, they knew tape, they knew scissors. And so we built bridges that could span distances, and we could put their books on top. We did some other things with electronics, based around that, but they were inspired. And the first few kids thought that was silly. And the next class, the same kids that had a lot of fun, putting all their books in their backpack on this straw bridge, it got a few more kids to come play, and join, rather than go and play video games, because that's really what they were doing with Scratch. And I didn't mind, it's what it is. You got to inspire them in some way, shape, or form. It's all about inspiring.
Yeah, it really is. And I like your escape room examples. I think one of the models I saw at Maker Faire quite a bit was makers created projects to interact with other people. They'd like a game, and it was playful. It was just, did you enjoy it? It wasn't always, in a sense, useful, right, or functional. Yeah. It was, oh, this is interesting. And, it's like, you build an escape. You want to see how people would interact with it, and the fact that you could dial it up or down is kind of fascinating. And it's like someone who builds a board game. It's just, there's a set of rules behind it. And you expect, your user or your gamer to interact with it a certain way. And sometimes you're surprised, you're surprised what they enjoy or what they find frustrating. So anyway, it's a wonderful model, though, right? Is in some ways, even video game is build your game rather than just play your game. And see what you learn from exposing other people to it.
One of the things you said when we opened up is like the maker communities the last year or so have been getting involved in solving some problems with the pandemic. I had an experience with the Tokyo Hackerspace in 2011 with the earthquake here in Japan.
Yes,
which was I can assure you of non-trivial size, I was involved with the Tokyo Hackerspace at the time, but I was also involved with many other international communities and Japanese communities in Tokyo at the time. Well, I was at Sun doing Open Solaris projects. And those people came together immediately and started building, radiation probes. And these were not people who had, the experience in doing that, but they had experience in building something. right? They had electronics experience, they had software experience, they had, whatever. And they simply reached out to physicists in the area and nuclear engineers and brought them all together. And it was an amazing thing to watch, and they actually formed a separate group called, Safecast, and that still exists, today. And it goes to, this whole concept of, some of it is play. So you're exploring solving a problem, right? But that's just the education of your mind on how to transcend and how to get deep enough into, solving a problem. Because when something really important happens that society needs help with, it can be implemented very, very quickly.
Right.
And this was an extraordinary thing to witness. I just witnessed it, from afar. But
no, it was really incredible effort. I mean, and it's, for those who don't know much about it, it's sort of like portable Geiger counters that people could take around. And again, it was driven by, just as I was talking about with COVID-19, there was a failure, a societal failure to report accurate information to people whose lives were impacted by this. So it's kind of, in the COVID sense, it's like it's happened in America. They weren't telling you, the infection rate. They weren't telling you the mortality rate. They weren't telling you where people lived who had the COVID-19, and they didn't seem to know. And so I thought it was a remarkable project, but it also highlights another thing we haven't necessarily talked about, but I think it's important, is that how you can, it goes back to your stereo idea in a way, is how you can build new things with kind of standard components, and just by mixing different hardware, a different sensor, different microcontroller, having the software to control it, that these things are pretty affordable and accessible to more people. And instead of building one of something that would be really expensive, you can build many of those things. And it changes how you think about it. So the Geiger counter was portable. It wasn't fixed. People could drive around and see what the readings were because they could put it on battery power. And then they could collect the data, upload it to the web, and it used all the, hardware, software, data, all of what we kind of call Internet of Things today, but that's really powerful. Just a pitch in a little direction. This is a CO2 monitor, and been writing about it on our thing because, as we start to emerge from COVID-19, and we get back into offices or classrooms, one of the questions, the advice is to ensure proper ventilation, right? To ensure exchange of air. But how do people know that? I mean, you could see this is going up because I'm talking near it. Everybody, exhales CO2 in a room. I'm up over 1,100 right now. So people talking in a room produce CO2, and it's a pretty good marker for the kind of particles that we put in the air that can contain the COVID virus. So if we want to reduce our risk, we want to keep rooms ventilated so that the air comes in and out. And again, but just like the Safecast, this is a board with a CO2 sensor in it, a display and a microcontroller is processing it, and we can upload the data and see how it goes. But, you can put it in a classroom and see when it starts to spike, and that tells you should open the windows. And, what people do often though, is they open the window because it's cold outside, they close it right away. And so it comes down, but it goes back up. And so they have to observe those patterns, and this little device, can help them do that. So, there's information on our site about it, and be in the next issue of the magazine as well, a project on how to build them. And, the point is that you can build them a lot of different ways, different form factors. But, I think, how do you get them in the hands of lots of people? Right. And it's a great school project, for instance, like build one of these, because unlike temperature, which changes gradually, CO2 changes immediately. You start breathing near the sensor and it goes up. So, the person, Guido Berger from Germany, had begun doing some work on this, and he built a kind of CO2 traffic light, which, it would be green if it was if it was safe, and yellow if it was starting to, increase, and red if it was getting into serious territory. So it's just, but what's fascinating to me is not just the geeky side of it. Is you can view it as a health messaging system, right? It's like, how do you get people to be aware of something they can't see, which is the particles in the air or the CO2? And and on a bigger scale, we just take room ventilation for granted. We think our HVAC is going to just take care of that, but we don't know if it's exchanging air or just recirculating air. A lot of interesting things that I think anybody could investigate.
I was actually in a mall recently with my daughter. We were having dinner at like a food co-op place, like a food court place, and this is a new mall, and they had the ceiling was basically a drop ceiling, but it was invisible, so you can see all the pipes above, right, it's kind of like a false ceiling. My daughter was fascinated by it. She says, "What is that?" I said, "Well, that's all the systems to make air flow through the building, to bring in fresh air, to remove all the dirty air, and the filtration systems, air conditioning systems, heating systems." And we traced it actually for a while, and to see, actually where it led. That's a whole engineering discipline of how you flow air through large structures, or like a tunnel or something like that.
The dynamics. The math is very complicated. Talk about something that you can teach in school, but not necessarily have a reason to use it until you want to figure something out.
So Chris, I'm getting all kinds of new ideas here from Dale. So tell us about your Pi. What's up with that? You've got two versions. You got the Monster Pi cluster, but then you have a smaller version as well.
Yeah, there's the 1024 Raspberry Pi cluster, the world's largest that we know of, because we just didn't get the Guinness Book of World Records because COVID, all the lockdowns and stuff. We're on pace to do that. We have some plans with it. Stay tuned. We're kind of it's in a lab. I can't actually get to it right now. Things are opening up, but we'll see. I think. Stay tuned. I'd like to donate it to the Tech Museum so everyone can look at it. It's a really neat art piece. And since then,
you have a picture of it? Yeah.
We had a deadline. We had to show it at our yearly Code One conference. And so that one, what we did was we, building the thing was enough. It was, I think I coerced about 50 people to come and help, just plugging in, you have a network cable and a USB power cable. And we went through lots of different iterations, lots of different thought processes of, how to accomplish this thing. How big is it going to be? Just how much power it's going to take. Cause it ended up pulling about 160 amps. So it's the better, bigger, a little bit more power than you could use at home, at your average home. Yeah. And so we had to get a lab for it at our campus. Solving all these different problems. Some of them I never even thought that I'd run into. There's over 255 devices. Your normal home network can only handle 255 devices. So we had to go to the Class B, networking. So that was a challenge. We also had proxy servers to deal with once we went, to different venues and the lab and stuff like that. So, there's just lots and lots of challenges. So we finally got it down to a size and everything that, and a form factor that worked pretty well. There's one side. There's another side that's just has actually just a fewer racks, but we broke these up into modules. So if you see all the blue, so one row of blue, and then there's a row of silver, that's the switches, and then another row of blue. So there's what we called one module. One row of blue is 21 Raspberry Pi 3B pluses. All the power is on the inside and all the networking is on the outside. So it seems obvious now, but it took a while to kind of try and figure that layout out. The there's a little card, I call it a card, but a little rack piece that a Pi slots into. There's a threaded insert and one little bolt. I have a video somewhere about how to assemble this, and I did it on my blog as well. And I could put something together to be more, one-stop shopping about it. I've been meaning to. It's just been, time. So you have 21 of these little racks, and then you have 2 end caps, and those all slot on a piece of 18-inch extruded aluminum. But the racks are 19, and I don't know. I can't remember the sizing of the racks off the top of my head. But I had to mill off 6.38 millimeters off the ends of the extruded aluminum, and then tap both ends. So once you have this, you have a sandwich of a Pi, this one Pi, 21 Pi in a 2U rack. And so we had this one module, and you can see there's 4 quadrants on each side. So there's 3 of those at the top, on the left-hand side, the right-hand side, 3 at the bottom, left and right. Same with on the back, but this one on the left has 7 modules. So yeah, there's a lot of wiring. It took a lot of time. The whole thing is network booting. So there's no SD cards in the entire Pi cluster. And that was a feat in and of itself. If I didn't have an operating system team helping me, the Oracle Linux team made that happen. We got it working with Ubuntu, and I'm going to stop sharing in case that messes your video recording up. So we had it booting with Ubuntu and Raspbian, but we had to go rebuild Raspbian to do network booting because you don't want it writing back to the server because you don't want to open up 1024 NFS volumes. That's a lot of work. So we wanted to open up one volume, but if they all write back, then they're messing up each other. So we had to do in-memory file system. So when you're doing in-memory file system and network booting, you can choose one or the other, but it doesn't really work. There's no just turnkey solution to do both. So you really have to start with either overlay file system or network booting, and then add the other. And then go rebuild the kernel, and lots of stuff I never did before.
Right. So kind of gets to a point, just to bring it back into I'm fascinated. Like, you did this. You did it as a project, and I when I started making this, I find people doing stuff like this. And how can I share what they know how to do? And it's really what I call know-how. You tried these different things, and if you didn't try them and actually try to do it, you wouldn't have thought about the issue with the NSF file system or the operating system. It's like you didn't have a plan that said, okay, this is like, now we see that's a problem, and then there's the next problem, and you really have to kind of go down the list. You keep creating problems that you have to solve to get to the next. It's a little bit of game-like, right? But it's fascinating. And it's maybe just for the audience is it almost goes back to my days at O'Reilly is how do you share, what someone has learned how to do so that others can do it, to replicate it. In other words, there's a way we could even say what you said, someone could get the basic idea of what you did. But the more details, the more helpful it is, right? If you say, hey, it fit into this unit, we had to, shave off the ends and do these things. It's really hard work, and I know, it's just that is, as kind of going back to open source. One of I think the ideas that I had around Make was that the procedure around doing what you did. How could we open source that, right? It's not code per se, but it is a kind of code, right? Which says, this is how I did this step by step. And so someone can replicate it. It's not compiled by a computer, but someone can take it. And they might make different decisions, around, I have a different housing, or, we're only going to do 512 Raspberry Pis. So we'll figure that out.
Yeah, no,
but, it's just like that's the fascinating part, because sometimes people or technical people just swallow that know-how and they hold on to it and they don't share it. and the world's better when they do.
No, I totally agree. Like I said, I'm sorry I didn't write a comprehensive article or something about it. I did blog about it, but there's friction with blogging. It takes time and video as well. And, that's why I document as much as I could while I was doing it. But inevitable, there's decisions that I had to make every project, case in point. So I actually, of all things, recently published this on Make Magazine as one of the projects. So, here's my very first computer is a Lego computer, and here's a 15 times 3D printed computer running a Raspberry Pi touchscreen inside. So it's got a battery and everything. So that's.
And you built that in your garage,
fun.
right?
What's that?
You built that in your garage, right? Everything from scratch.
Yeah, I built it with a 3D printer. It's actually two parts. It prints like this. My printer's not quite big enough to print the base of it, but it's one giant Lego block. And
that's great, Chris.
It's yeah, I don't know. It's fun.
So let me ask you this, because it's a kind of a playful thing, but so people look at that and they go, well, what's the purpose of that? Who's ever going to need, a Lego piece with a Raspberry Pi computer in there? And it's kind of like asking, why does someone need, a symphony or other things? It's a piece of work, right?
Right.
And it demonstrates some abilities. Yeah. Yeah.
It's for me, I got the idea because I've 3D printed, giant Lego bricks, for a while.
Yeah.
And I can't say that I was the first one that did it. There's other people that have been printed giant Lego bricks on YouTube, and I did it before I saw them do it, but they published first, and I go, yes, there's someone else that wants to do that. And so, like you said earlier, it's about sharing.
Yeah. And it's by sharing that you make those connections to other people that have the same interests, and kind of going back to your original point, that's how you build community. It's because you find out that there are people like you out there who have similar interests. You didn't go to college, you don't work with them, there's no other connection, but they like Lego, building Lego, 3D printed Lego bricks, and they're experimenting with that. And it's like, cool,
That Lego brick, it gives me a smile every time I see it. And when I boot it up, it's got a little the original screen, and I from what a Lego has, and I've started some software on it. I was playing a video game on it at first, but it needs its own Lego software, if you will.
Yeah.
So yeah, it's I don't know. It's art. It's an art piece. It's about the technical challenge. It's about, can I do it sometimes? It's not just. It's taking your own ideas seriously too. Yeah. Even though they might be silly. It's. I think making, the simplest definition I have, it's just turning an idea into something real, right? And having to iterate and figure that out. And it could be, your monster pie cluster, but it could be a Lego brick. And, I think the tragedy is a lot of people discard their ideas. They don't act on them. And, that's not important, or nobody really cares if I do this. And, but you care and you try to do it, and good things happen. I mean, that's where I think the good karma from the community comes is when you put all those people together. I never knew what would show up at Maker Faire. But that was the fun of it. We never had a call for, we're looking for sustainability projects. It's just whatever shows up, and it's delightful. It's intriguing. And I think it's also innovative, because it's kind of a very raw form of innovation, that people do things because they can figure out how to do them, and they don't always know why they're doing it. I think it's a renaissance.
Yeah.
And if you a few years back, we went through Florence, Italy, and some other places, Venice and stuff. And the art, the statues, the things they did, they didn't have I mean, granted, there's the kings and stuff like that had tons of money to throw around, and they got the best of the best but they wouldn't have done that if they weren't good and they weren't trying things. And it wasn't, someone, there was someone that was funding it. Obviously they wouldn't be able to do it otherwise, but there was plenty of them that were probably doing it just because they wanted to. I don't know what it costs to get a chunk of marble, but it's they just wanted to try, to do it, and they built made things, and they got commissioned to do it. And a lot of people, they take their making very seriously, and then they get a job doing that.
Yeah,
so
absolutely.
It's
experimental.
It's like video games.
Right?
Yeah,
absolutely.
It's like video games. There's esport now you can actually make money playing video games for a living.
So you guys are talking about
human nature.
So you guys are talking about art and desire and, all this. Dale, when you started this whole movement, you were at O'Reilly at the time, and O'Reilly was at the center of the open source community. And you had something new. You had a new idea. What was it like starting something new within that organization that was more hardware based? I mean, that was obviously O'Reilly as a publishing company, but they were focusing on this revolution of open source. What were some of the conversations like back then? What did people think of starting a physical magazine on paper? Talking about actual physical.
Well, I was lucky that I had just a good partnership with Tim O'Reilly, and he said it sounded interesting to him and encouraged me to go ahead and do that. And I have kind of a track record of doing those kind of things. So
no pushback, no
no, not really. Yeah.
Really? Wow.
Over time, sometimes, it's like, how much is this going to cost and everything. But
what about from the community?
It's an interesting connection. I've told the story before, but I told Tim about the magazine in a cab in Portland, Oregon, on the way to open source convention. We were sharing a cab, and I said, "Hey, Tim, I have an idea for a magazine. Think of it like Martha Stewart for geeks." And he said, "That sounds interesting." And the point is, like, I wanted to share the details of projects that you could do, cool projects, things that were fun. I was inspired by when I had the idea to go back and look at popular science and popular mechanics in the 50s and other times. And, they were really broad-based magazines on, hey, if you're a farmer, you can do this. If you're a sailor, here you can do this. Or here's a 3-story Martin birdhouse. And I like that sense of adventure and openness, whereas a lot of the technology magazines we get are based on, especially at the time, where, laptop world or whatever, or Mac world, they were based, on a narrow selection. And I just had this idea that in some ways we're doing open source for hardware and for projects rather than, just software. And it had these other, interesting considerations, because you have to do hardware in a place. You need to do it on a kitchen table or at a workshop or a maker space. You couldn't just share code online and be done. So, and I think it just brought in new skills and brought people a little bit. I think what Tim and I think did, it's how we got into open source, how I got into the World Wide Web really is, I just followed the interests of people, not because they knew where they were going or I kind of thought of it as pre-commercial, because there was no business model for the early World Wide Web or for open source or anything. It was just people were doing it. So the fact that they were doing it was enough. It was a starting place to go along and begin to figure out what you could do with that. And, I just began, had this idea, and I began finding more and more projects with robots or rockets and all the things that, you might see at a Maker Faire. And I just saw them as related to each other. And I think prior, nobody kind of thought that they belonged. And still some people don't, but, the spirit behind it the people and the enthusiasm. And I like to think kind of in my career, both through O'Reilly and other things, is I was trying to find and follow enthusiasts. And they took you interesting places. The early computers built by enthusiasts, and the Homebrew Computer Club and the West Coast Computer Fair and all that. And, it's just, that's such a foundational element when I think of the tech industry that I think we, at various times over the last 20 years, we've lost those roots. We think it's kind of today the venture capitalist is on top of the world. We think they're the most important element of it. And I'd argue, no, it's not them. They are laggards in this. It's really the enthusiasts, and they're way out ahead. And often, money just becomes a distraction and a disappointment, and raises expectations that there are a bunch of people going to make money off of a technology, when in fact, the technology has its way of seeping out into society and being used in lots of interesting ways. And we kind of miss that because we just focus on, a single company making a lot of money. And that's kind of comes back to this idea of hacking and, find what people in your own community are doing and get involved with that. That's how you learn, how you participate, how you enjoy it.
Yeah, one of the things that I've been learning about the various Oracle communities, there's a lot of older people and there's a lot of younger people, and they mix really well. And the younger people, these are people who are 30 years younger than me. I mean, this is really a lot younger, and they just have a totally different perspective on things. And, that's what we're trying to do here in our jobs, is to reach out to these people and engage them through obviously online more recently, but through physical things, user group meetings and conferences and these kinds of things. But just not just bringing people together for, to look at slides, but to actually, build something together,
Yeah.
And we do a lot of, hackathons and these kinds of things, to sit down at a computer together and build something, that's all software based, but you can do something similar with Chris. We should bring, Make into the developer lounge and have like a joint event, right? I think that would be pretty cool at the next, when we're allowed out again. What do you think?
Yeah.
Well,
it'd be fun.
I think, one of the things in companies like an Oracle, I always thought it would be fun to, in effect, do some version of Maker Faire. Actually, in the Bay Area Maker Fairs, Oracle has done some Maker Fairs internally.
Yeah.
But,
we have.
I thought the core of it is ask people, to bring in some of their side projects, things they're doing outside of work.
Yeah.
And you learn an awful lot about them, right? And you don't know that they're, building an airplane in their garage, or a jetpack or something like that. But it's because nobody ever asks them at work, what is that? And it's fascinating. And so I think one of the big things around this, like the meetings you're talking about, it's almost to make some of the things that happen in private, help them find their way into some kind of shared public space that is safe and non-judgmental, and where people are generous with each other. And I think that has to be part of that community. It's like you don't want to, I get some makers a lot. Is like they kind of freeze up when they're getting judged. They want to keep in that. They're stay in that playful space where it, you could fail at it, and just like a game, your character just is reborn and you start over again. It's not like the end of career. So I think that's one of the reasons why makers can be innovative, is they can take those risks and not worry that it's going to, be the end of things.
Yeah, the case in the Pi cluster, I didn't quite answer your question what we ran on it. The first thing was an open source, software that we actually hired a company, Gluon, to build that and run Java and JavaFX and a bunch of the Oracle stack. The second one, the smaller ones, we ran SETI at home. So I was searching for aliens on the 84 Pi cluster. And so But anyway, people also ask what made me think about that is people also ask, why? Just like you asked with my giant Lego. And it's, with that one, it's because it's about the things that you don't know that you learn. So internally at Oracle, I was saying to various VPs and directors, management chain, this is bringing teams together across the company that don't normally work together, and they're learning things. They're learning to solve problems, and they're learning to work with those people. So they're making those connections, and they're learning these problems that they might not use it, next year. They might not use, even tomorrow, but maybe in 3 or 4 years, that might be something that they need to know. If it doesn't, it expands their horizon and the creativity. I'm always a big proponent of music or other things. They influence your day, programming, for instance. Music influences programming. There's a lot of musicians, programmers that are musicians, and I think that works for a lot of different fields. You cross pollinate, if you will. That giant Lego, I have plans for it. Not only is it just a personal thing that once I got the harebrained idea to do it, I have some things around the house that I just want to have this giant Lego sitting around. So it's just displaying things, and it's just fun. And I want to put hook a camera up to it and tie it in with my day job, so I can hook it up to OC, our Oracle cloud, so I can justify having other people around the world print these. And then imagine if we could run Zoom on that giant Lego computer. Be fun, it's neat to just the reaction, the smiley that you guys are getting. So many people have seen that giant Lego computer, and at first they're just like, what? And then finally they're smiling, and that's what it's about. You mentioned the Makers Fairs. Those are, I've been to a dozen or half a dozen or so. They're amazing. They're it's inspired me. So thank you.
You're welcome. Well, we hope we can bring them back next year somewhere, particularly the one in the Bay Area. But
that'd be great.
It's our challenge.
Yeah, I think that's probably, they'll probably emerge sporadically around the world where they can. Yeah. Right. Start small and then grow. But I really do think that it will come back, because this is the innate human desire
exactly
to get together and to collaborate on anything, right? Community building really leverages the innate human need to interact physically.
Yeah, absolutely.
The virtual stuff is okay for now, but it just does. It's not a replacement for. I would love to be in a room with you guys right now. That's so I can, so Chris can hand his Lego over to you and to grab it,
right? Absolutely,
look at it. It's this visceral thing. So
I think it's even in terms of events. It's just the unexpected, elbow, that you get, that someone says hello to you and you start talking about something. Well, that is priceless, really. And you can't figure out how that happens or why that happens. It just does when you get a group of people together.
I look at the whole online thing a little differently. It's unfortunate. I want to be in the same room and all that. There's advantages, but just like any problem that anything you're trying to build, any problem you have, if you're given unlimited funding and unlimited time, you never necessarily build the right thing. Creativity is spawned by having the lack of something. And so with this online, it's forced me to be creative and try to figure out how to bring things together, how to do things and do it virtually. There's video games is a perfect example. They've been online for ages. So can we leverage that ties into the day job of Oracle Cloud. So it's like, can we run it on there?
I think it's a great example of just, I think the future is hybrid. It's just trying to figure out the way these things can be both. An education example is, I hope that one of the lessons our education system learns is that hey, students actually can learn online, in a variety of ways, not necessarily the ways they were using, but, if you think about a ninth grade student who has, one option for a computer science class when there's dozens of options online that they could take that would be equivalent, why not expand the menu of choices for students so that they could figure out that there's a class and a kind of teacher that they like the best and works for them, and they actually learn the subject, so that's what I hope. But I think events too will, we're able to bring in people that can't travel or live in that geography. And I think figuring out ways to do both of them together will be really powerful.
Yeah,
excellent.
I totally agree.
Okay, guys, it's now 3:13 in the morning, and let's get out of here.
Jim's tired.
Because Jim's going to go to
Jim.
bed.
Yeah.
But this was great, Dale. I really appreciate it. As I said before, Chris and I have been wanting to chat with you for a while. Great to catch up. And we've got a whole bunch of new ideas. And next time we meet, we'll do it at Maker Faire.
That's wonderful. All right. That's great. Thank you very much.
Can't wait. Thanks, Jim.
Thanks. Bye-bye now.